Hi, Dr. Hyun. This is my second report. So I thought about why my previous calculation didn't work out. And so I read more about where I got the equation from. And it turns out when they were referring to the thickness of the web foam layer, they weren't talking about the thickness of the web foam's film, but they were talking about the thickness from the bottom of a drain foam, bottom of a um, part where the liquid surface and the foam meets to the part where the wet foam start turning into dry foam. So that's why we had such a big discrepancies between my theoretical value and the actual value. So I looked up the thickness of the bubble film, and it ranges from 10 to 1,000 nanometer, and these values are comparable to 200 to 600 nanometer of the alveolar wall's thickness. And in the literature that you gave me about where was it? The study that you recommend me to read, they used the value of 0.025 millimeter, which is 25,000 nanometer. So there's some difference between their values. So I need to revisit and read more about it. But they're still in the similar range. So I came up with two key questions. And one is what kinds of physical models can explain the physics of respiratory system? And in my hypothesis, I'm using foam. Currently, I was focusing on liquid foam, but liquid foam, and I think there's some resemblance with open and closed foam with lungs. I'll talk more about it in the next slide. And if my first question turns out to be right, I can ask second question, which is, can this model inform our understanding of lung functions and dysfunction? For example, for infant respiratory distress syndrome or with atelectasis, they're both caused by a lack of surfactant and making their alveolar to collapse because of the excessive surface tension pushing the alveoli to the inward. And we know that the surface tension plays a big role in foam. Or with pneumonia, which is a swelling in lung, I think it might be interpreted as increase in liquid fraction. And one of the studies that I read about foam is it said that the increase in liquid fraction can lead to the loss in elasticity. And because elasticity is related to compliance, I think pneumonias can lead to lower compliance, and maybe we can use some characteristic of foam and play with some physical matter with foam. And that could be that could lead to potential treatment of pneumonia or other dysfunction of lungs. So we have similar things going with pulmonary fibrosis or emphysema, which both deal with compliance. So as I look more into lungs biology, I noticed that their pictures looks pretty similar to of like open cell foam, but I haven't done any intense research about it, so I don't know much. But I'm going to look into it more. So I read a few studies, but not many of them were so helpful, especially with like foam studies about foam. They mostly focus on about like the foam drainage of where the liquid in the foam drains to the bottom, so like the wet foam slowly turns into dry foam. And I didn't think that was really helpful in studying lungs, because the gravity, like the structure of lungs doesn't really get affected by gravity as much. So this is the study that you recommended to me. Recommended me to read. Um, so their result was kind of intuitive and as expected, that the unhealthy lung shows higher resistance and lower flow rate and uh, low compliance than that of healthy lungs. And this one is about foams. And I found it helpful because so this study showed that as the liquid contents gets higher, the elasticities gradually start to vanish. So it gave me an idea that maybe you could look more into characteristic of lungs physical characteristic and applied it to lungs like structure and study the dysfunctions, and it could lead to like potential new treatment by controlling the relevant physical matter of foams or lungs in this case. So what I'm planning on studying now is more details of alveolar functions, like the biology of it, and just physics in general, because many of the foam studies that I read included lots of physical jargon and like stuff that I don't really know or learned yet. So I'm going to look more into it, and I'm also going to look into various lung diseases. So I think that knowing what affects what, like the I also need to study more about foam's parameters effect on physics. Um, I just need to learn more um, about foam because there are a lot more to learn. And so far from the study that I read, I learned that the increase in liquid fraction may lead to may lost in elasticity. So that could be applied to our lung, where if our lung gets too much of a liquid or cells, they this, our lung may lose elasticity or compliance, and that could lead to other dysfunction. What I need to do is also revisit the alveolar geometry. There were some discrepancy between values of alveolar wall thickness. Um, from like Wikipedia and other like medical textbook, it says many of them says the alveolar wall thickness are 0.6 micrometer, but like few studies says the alveolar wall thickness are like 0.025 millimeter, and they are not quite close. So I need to make sure I'm using the right number. Thank you for your time, and appreciate you for guiding me through this whole process. Thank you.